Hi everyone, I am Saniya, and in this video, I want to show you how you can use Pandas np.where to help you create columns from your data frame based on values that you're interested in, which could be extremely helpful in various situations. So if you have a set of data, if you have a data frame with a set of values for various columns and you want to derive other values and columns based on those, how do you do that? So let's get started. And the data that I want to look at here will be from Kaggle.com's housing data, house price prediction, predicting the house price. So the real estate markets like those in Sydney and Melbourne present an interesting opportunity for data analysis to analyze and predict where property prices are moving towards as well. So prediction of property prices is becoming increasingly important and beneficial. The property prices can indicate overall market condition is good and the economic health of the country is good as well. So they're looking at a large set of property sales records stored in an unknown format and with unknown data quality issues here. That's what they're looking at here. They have date, price, bedrooms, bathrooms, square foot of living, square foot for lot, number of floors, waterfront, is there waterfront or not? It's binary 0 or 1. If there is a value, if there's 1, that means there is a waterfront, otherwise there is not. 0, 1. You can also sort it here. You can sort it in descending and see for the waterfront what that looks like. If there's some that have waterfronts, views, conditions. There's so much here as well that's also not seen as well. And in particular, they have the year renovated that we're going to look at as well. They just showed the top 10 of 18. So I downloaded the data and I uploaded it into my Python notebook here. So the file name of the data set is housepricedata.csv. Again, these are free files. And I read in the CSV file here. So I imported pandas, these little guys in the back, pandas, hi little guy, as PD and numpy as np. And I'm reading in the CSV file here that has 4,600 rows and 18 columns. And what I want to do is I want to do some exploratory analysis, but my key question, so we notice for year renovated, so if we were to just look at year renovated, so data df, I can look at year renovated. I can do something called value counts. This will break down the counts of year renovated, the number of rows with each year. So we're going to see that, if we look, there's some in 1953 that were renovated, 1948. These are various number of rows. So we have about like 170 rows renovated or houses renovated in 2000, 151 renovated in 2003, 109 houses renovated in 2001, and in 2009, 95 homes renovated in 2005. But there are a lot that have 0. So it seems that the way that the year renovated variable works is that if year renovated equals 0, then that means the house was not renovated. Otherwise, it's equal to 1. Oh, no, otherwise it's not 0, but that's what we would want. Else, it is the year the house was renovated. So that's a typical rule. So if year renovated is 0, the house was not renovated ever. It's the original. It is original. Otherwise, it is the year that the house was renovated. So that's what's really important for us. And I could come up with another column where I could just say renovated, and I can do data df columns just to make sure I get the spelling right, just to list the columns out. Okay, so I could just say that renovated df is just data df data df. I'm just filtering based on the rows. Year renovated is not equal to 0. And I can just see those rows here. And based on that, I can see that all of these do not have a year renovated that is 0. These are all renovated homes. So let's say I want to make a column. I want a column that is going to be, I want a column, an additional column here that's going to be renovation, was renovated. I want to make a column that is called was renovated. Essentially, this column is going to be right here. And it's going to tell me was this home renovated or not. I don't want to make it in the original data df. Was it renovated or not? So what I'm going to do is I'm going to say that if it was renovated, if true, I wanted to say was renovated, and value if false is that not renovated. I want to have those two values in my column, either, so basically for anything, I want to have this column right here. And essentially when year renovated is 0, I wanted to say that it was not renovated. I wanted to say that, hey, it's not renovated. And for the others, I wanted to say that it was renovated. Renovated, and this one is renovated. I don't know about what's in between, but we can say for those that it's renovated. I just want that, basically. About the font, but that's basically what I wanted to say. Either not renovated or renovated. So those are my two values. So because I've already, so basically for these, I wanted to say it's renovated, and for the other ones, when year renovated is 0, I wanted to say not renovated. And because I have already, at the start, I religiously always call these import pandas as PD and import numpy as np. These are like the nicknames. I always like my little panda buddy. High five, guy. So yeah, he's my little buddy in the back, little cute little panda dude. I always import them at the start. Import pandas as PD, import numpy as np. So after I've imported them, then I want to show you now how I can create this column that I want. And the column name is like was renovated. And basically the idea is I want to create in my data df, I want to create that new column was renovated. So data df column name. Actually, I can call it new column name. This is the name of the column we want to add. Maybe I can add, like, I can make this an underscore kind of going off of what they're doing, square foot basement, square foot above, square foot lot, square foot living. And this is if basically the way is that if year renovated is not equal to 0, otherwise year renovated is 0 and the house was not ever renovated. So I want to then go here and put my new column name in here, and then just set this equal to np.where. And this where is where I'm going to have my condition. So based on the rules of NumPy, the first thing that I'm going to put is I'm going to put my data frame. So data frame here and the columns that I'm looking at. I can have these all in like the first set of parentheses. So the column that I'm looking at here is going to be year renovated. It can be multiple columns too. We'll just see another example, year renovated. Where year renovated is not equal to 0. That is the condition. If year renovated is not equal to 0, then I want to have, then basically it was renovated. That's the idea. So if YR renovated is not equal to 0, the house was renovated. Else, house was not renovated. That's the key rule we want. And based on that rule, if data df year renovated is not equal to 0, then based on that, the house was renovated. So I have my value if true. The value if true always comes right after this. Then value if false. That's how the argument goes. You have a condition, so it's basically np.where. You have some condition, value if condition true, value if condition false. That's how this works. We have our np.where, we have a condition that we're checking, or multiple conditions. A value if condition is true, value if true, and then value if condition is false. That's basically what we're trying to do. So I'm just going to write this below. We have data frame. We have a new column name that we're trying to add to the data frame, np.where. We have a condition. We check value if condition is true and value if condition is false. And our condition is basically this, checking if data df.year renovated is not equal to 0. And if it is not equal to 0, we have the value was renovated. Otherwise, we have not renovated. So I run this. And then after this, I'm going to see what my data df looks like. Okay. So great. We've added in from before. We had just country, which is all US, but we had just 18 columns, 4,600 rows. And now we have 4,600 rows and 19 columns. So we added this column was renovated. And just as we wanted to see, we see that whenever the year renovated is 0, we have not renovated all the way here, just as we wanted. And the other ones have was renovated. So that is pretty cool. That is pretty cool. You can also have another condition. Like let's say that we also wanted to say that, hey, if this house is very old and it also is not renovated, then maybe it needs repairs. So I can add in another column like needs repairs, because you might be wondering, like, what if I want to do this for multiple columns, not just a year renovated, but multiple columns, and how do I do this? So I can say needs repairs if true. No, maybe I can say does not in good shape. And I can say needs repairs. House status. So maybe repair status. So the idea is that if it's not been renovated and it's very old, maybe I think it's pretty old, right? So if it's good shape, if year renovated is not equal to 0, actually, let me switch it around. Let me say needs repairs. Let me do it this way. And let me just say good shape. It's in good shape it needs repairs if year renovated equals 0, if it's not been renovated, and year built is maybe earlier than, let's say, 1950, maybe 1960. So it needs repairs if the year renovated is equal to 0 and the year built is 1960. Otherwise, if the house is built after 1960, built on 1960 or before, built after 1960, or has been renovated, then it's good. So that can be the rule, that the house can need repairs if it has not been renovated and year built is less than or equal to 1960. So now that we've created this column, we can do it two ways. So I'll show you one way. We can either say if year renovated equals 0. Okay, the new column name, which is repair status, where data.df year renovated equals 0. And then the other thing we can do is just also add in essentially an and. That's how you can check multiple conditions. And data.df dot year built is less than or equal to 1960. So I recommend just keeping this value if true, value if false, and then just adjusting these so you can keep track of the logic. You want to add a new column, repair status. Like here, we added a new column, was renovated here. That's what this new column name is. Add this new column. And the set of values is was renovated or not renovated. Those were the values here. So similarly, we want to add a new column, repair status, with the values needs repairs or good shape. And it needs repairs if it has never been renovated and it was built before 1960. So idea needs repair, house probably needs repair or renovation if it was built on or before 1960 and has not been renovated since. So unless you're going for very vintage, but even if you take a very old home, like that's really cool, if you're doing colonial times, be prepared to have to do some upgrades from time to time because stuff falls apart. So let's see now if we can find any homes. So this is how you can check for multiple conditions. You can have this ampersand, this means and. So data.df year renovated. This part is essentially, this part right here has not been renovated since, is this part here. And the other part of if it was built on or before year built, that's what this condition is checking. And the and is just like the and here. Now has not been renovated since and was built less than or equal to 1960. So it could be built in 1960 or before, which is like 1959, 1958, 1930s. So once we run it, we see homes repair status, needs repairs, or good shape. So for instance, this house needs repairs because it was never renovated. So you can see here that it just never was renovated. Even this one says not renovated. And the year that it was built is before 1960. This house is old. It's built in 1921 and it was never renovated, as this shows. Another way we could have done this is we could have also taken advantage of the new column that we had called was renovated. And we could have also just said, instead we could have said not renovated. So that's another way we could have done it. We could have used this new data on renovation. But in any case, I just hope that this makes sense, and I can also keep track. Maybe I want to see how many homes do we have like that, so I can look at repair status, I can do the value counts, and then get results that way. So it seems that we have 598 out of this 4,600 rows. 598 homes do need to be repaired, and the good thing is now I can actually, focus on those homes that need to be repaired, and I can analyze those. I can say needs repairs, and then see which ones are in bad shape. Maybe I don't want to look at those. Right? Like if I'm looking at buying a house, for instance, I might not want to buy the one that needs repairs. So all of these need repairs. So this is me looking at the houses that need repairs, probably. That probably need repairs. So that's how you can do that. And you can see, again, they were built before 1960 and they've not been renovated. They need and. And the way to do that is, again, to have an and here, to have the condition 1 and condition 2. So again, the way to do it is for multiple conditions, you have like condition 1 and condition 2 here. Value if both conditions are true. Value if one or both conditions are false. For instance, that's how it goes. So we have the two conditions here. We have value if both conditions are true, and then value if one or both conditions are false. So we need to meet both conditions. Because if it was renovated but built after, so what I want you to see is that for the other situation, if it is not needing repairs, I'll just make it easier to say this. It's not needing repairs, not equals, again, what this means is just is not equal to. That's what this is, not equal to. So then if you say if it doesn't need repairs, it's in good shape. And I hope you see that we do have homes like this one that is built before 1960, but it's been renovated recently in 2005, so it's in good shape. Because we needed the two conditions to be met for renovation to be needed. It needs to be built before on or before has not been renovated. If you wanted it to be an or, what you would have to do is, let's say that we wanted to do or, instead of and, the way to do or would just involve changing, like if we just wanted to make some other column, like let me just show you. This instead, if we made or, I can just call it some other name and just trying out or. Then you could just say that this is or. This is an or. Needs repairs, good shape. The needs repairs would be pretty much anything, either or. That's what an or looks like. If you want to do something with an or. So this is an and. An and is this ampersand thing is for and this thing here is for or. So that's just a very basic guide for NumPy to be able to create columns, to do, based on rows, to be able to handle a lot of things. And I wanted to give a huge thanks as well to a source of advice and guidance when I myself was trying to figure out how to do this. One of my good friends, Stack Overflow, kind of helped me out with that because somebody had asked a very important question on this idea that how to create a pandas data frame column based on the existence of values in a subset of columns by row. So this question right here was actually asked. Somebody wanted to say that the values in column A, B, and column C are either an integer or zero. So if there is a value in column C and zeros in columns A and B, I would like one to be in the new column, in the column new column. So they want to add a new column here that is basically based on, so they want to add in this column right here. And essentially what the value is that if there is a value in column C that's non-zero, but there are zeros in columns A and B, then we need for this to be a 1. So if column A and column B are both a 0, which they are here, and column C is not 0, then make this a 1. Otherwise, zeros. So for instance, if all 3 are 0, then 0. If both are 0, B and C are 0, but A has a number, then 0. So these are the rules. So we need A to be 0. And B equals 0. And C is not equal to 0. This here, we need all 3 to be true for the new column to be 1. Otherwise, it's 0. We need all 3 conditions to be true. Otherwise, it's going to be 0. And the way that it was answered, which was very helpful for me, and that's how you add this, is to just say, hey, you have a df new column is equal to np.where df column 1 is column A is 0, and column B is 0, and column C is not 0. If all 3 conditions are met that I just showed you, if all 3 of these conditions are met, then we can say 1, this is the value if true. This is the value if true. And the other one is the value if false. So this is the value if true, and this is the value if false. Just as I had shown, but I thought it would be more intuitive to sort of, break it apart. Value if false. So that's sort of how to do it again. You can have multiple conditions, column A being 0, which is what this is showing, and column B being 0, which is what this is showing, and column C not being 0, which is what this is showing. This not equals is the same thing as a slash. It's the same thing as essentially, that's what the not equals to is. Then what happens is we put a 1 in this column, otherwise we put a 0 in the column. So that is the example, and you can do this with multiple conditions, adding and if you need to do this for with or, then all you need to do to make this an or is to just change this. You just need to change this right here from an and to an or. An or is just the pipe. Maybe you have an or, and an or is just a pipe. So an and is given by this ampersand, and an or is given by this, the logic. So I hope that this was helpful, and if this was, then please like and subscribe my channel, and please let me know if you need any more help. Please reach out to me if you have any questions at all. I'm Saniya, and I hope that this was helpful to you guys. Thank you and have a wonderful day.